Hello everyone. Do you remember what we have studied about P-type semiconductor and N-type semiconductor? Now it's time for us to study about a PN junction. So what is a PN junction? If we are taking a P-type material and dope it on the one side with an N-type semiconductor, the metallurgical junction that is produced as a result of it is what is meant by PN junction. So here we have to study the two processes that is involved in the formation of a PN junction. So this question can be asked as a descriptive question for the board examination. So what's the question, children? Describe the processes for the formation of a PN junction. So the processes for the formation of a PN junction is formation of a potential barrier, diffusion and drift. So let us study about the formation of a PN junction. So let us draw a PN bar. So how can we draw it? Do you remember how can we draw a P-type semiconductor and an N-type semiconductor? So P side, we know that it's an acceptor. It is a negative atomic core with a hole. You have studied it in the last class. What we have done, it's an equally spaced. You have to draw it like this with negative things. Here with the holes. Here with holes. Negative with holes. Remember, a P-type semiconductor is having an acceptor carrying an electron which is not its own. Then an N-type region where it is positive with an electron here, positive with an electron here, positive with an electron here. This is a PN bar. So listen, children, what happens when a PN junction is formed? So let us discuss what happens if the PN junction is formed. So this is a PN bar. So initially during the formation of a PN bar, what will happen? The electrons here are the majority carriers and the holes here are the majority carriers on the P side. So electrons are the majority carriers here and holes are the majority carriers here. Usually what happens when there is a concentration difference? If we think that electrons are more here and less here, what will happen? What happens is that the electrons will migrate from a region of higher concentration to a region of lower concentration. As a result of which the holes also migrate from a region of higher concentration to a region of lower concentration. So the movement of these majority carriers across this junction is what is meant by diffusion. So this is the first process what is happening during the formation of a PN junction. So what is it? The first process is what is meant by diffusion. So what is diffusion? The majority carriers, that is electrons on the N side, try to cross this region from here to here, and the majority carriers, that is the holes from the P region, move to the N region due to their concentration difference. So this process is what is meant by diffusion. So the first process that is going to happen during the formation of a PN junction is diffusion. So once again, what is diffusion, children? Diffusion is the movement of majority carriers across the junction according to the concentration difference. So what happens? Will this diffusion happens for a long time? So let us discuss the detail. When the electrons moves to this side and the holes move to this side, what happens is that there is a chance of recombination. You have already studied whenever temperature is there, electrons and holes are produced. That is what is meant by generation. So what happens is that during their random movement, an electron can move into the hole and there is recombination. So these are the two basic processes with electrons and holes. So when they try to move across this junction, what happens is that an electron, there is a chance of moving into the hole and they get neutralized. So within some time, what happens is that in and around the junction, due to the recombination of these electrons and holes, what happens is that there develops a region in and around the junction. Due to the recombination, what happens is that there is a region over here in and around the junction where there is no mobile charge carriers, the charge carriers that cannot move, but that is a space charge region. That means that there are charges but it cannot be moved. The donor atoms and the acceptor atoms are there in and around the junction, but they cannot move and they cannot contribute for conduction. Where are the mobile charge carriers? They have been lost due to the recombination. So, in and around this p-n junction, there develops a region where there is no mobile charge carriers. Such a region, I may call it as AB. This region is called a depletion region. This also can be asked as a question or a multiple choice. What is depletion layer or depletion region, children? It is the region in and around the p-n junction where there is no mobile charge carriers. Such a region is called a depletion region. So what happens when a depletion region is produced? Look at this area, children. It is just equivalent to a potential difference, isn't it? Some positive is there here, some negative side is here due to these acceptor atoms. So there develops a potential difference here, so that this negative acceptor course here will try to oppose the further motion of electrons from here to here, and the positive donors here will try to oppose due to repulsion. As holes are positive, these holes cannot move here due to the repulsion from this positive course, and the electrons cannot move to this side due to repulsion by the negative course here. So what happens is that the continuous movement across this junction is blocked. So it is just like a wall created. It is just like a barrier created, which will not allow the further movement or diffusion of electrons from this side to this side, and the diffusion of holes from this side to this side. So there is a potential barrier created or potential difference created across the junction. So what is that called? Potential barrier. It is just like a virtual battery fitted over here. Listen, children, it's just like a virtual battery. There is a potential difference created or a potential barrier created. Further, we cannot, or these electrons or the holes cannot jump over this potential barrier to cross this junction. So, what happens? Once again, diffusion happens. Then after that, what happens is that there is a chance of recombination. So due to this recombination in and around the junction, there is a depletion region produced. What is depletion region? A layer or a region in and around the junction where there is no mobile charge carriers. As a result of which, it is equivalent of developing a potential barrier or an electric field which will not further permit the movement of majority carriers across this junction. So the main processes happening in this is the diffusion, then the formation of a depletion layer, and the maintenance of a potential barrier in and around the junction. So the most prominent, the first process due to the formation of a p-n junction is diffusion. Here, children, there is another process. These are the two processes that we have to focus on while writing the answer. Another process that is happening is what is meant by drift. So you can just look at the figure in your textbook. So how can we draw diffusion? That is, here when we draw, this is what is hole diffusion, because holes are going from this side to this side. And from here, when we draw it like this, what is it? It is electron diffusion. Both are marked in your textbook. Please refer to your textbook. Hole diffusion and electron diffusion. So that is it. So what happens is that hole diffuses from left to right in this figure, and electron also diffuses from there to here. So what do you mean by drift, children? We already have talked about the minority carriers, isn't it? We were all time talking about the majority carriers here, and we have to talk about the minority carriers. Which are the minority carriers here? The minority carriers in the P region are the electrons. They are there. How they are produced? They are produced by the temperature. And in the N region, there are holes also, isn't it? And these holes are the minority carriers here. All this time we were talking about the majority carriers, right? So we have forgotten about the minority carriers. But there were minority carriers at the both regions. Can these minority carriers move across this junction? Think about it. Can these minority carriers? Of course, because the electrons are negative. This can be attracted by the positive course here. So, even though the movement of majority carrier is blocked by the potential barrier, children, think that a few minority carriers can move from the P region to the N region, and the holes, the minority carriers of the N region can move to the P region. So this movement of these minority carriers according to the potential created here is what is meant by drift. So in which way holes drift? We can just draw it. Hole drift, how will we draw? Holes are drifting from here to here, right? So hole diffusion is in this direction. The hole drift will be in this direction. So electron diffusion is in this direction, right? But electron drift is in this direction. This is diffusion and electron drift is in this direction. I hope that you have understood. So once again, to take a recap, children, what all are the things that is happening? First is diffusion. According to this diffusion, what happens? The electrons will move from the N region to the P region, and the holes will move from the P region to the N region according to their concentration difference. You know that everything in the universe moves from a higher concentration to a lower concentration. And after that, during this formation, what happens is that during this process, what happens is that there is a chance of recombination. Then what happens is that there develops a region in and around the junction where there is no mobile charge carriers. Nothing is there, only a space charge region is there. And this is what is meant by depletion layer. As a result of this potential difference, there develops a barrier which will not allow the diffusion of the majority carriers across the junction. So diffusion there is almost over, but by the time what happens is that the holes and the electrons are the minority carriers here, the holes are the majority carriers here. They move according to the potential difference. They can be attracted towards the negative. These electrons can be attracted towards the positive, and the next process, that is the movement of majority carriers according to the electric field existing in and around the junction, is what is meant by drift. So diffusion is the process of movement of majority carriers, and drift is the process of movement of minority carriers. And an equilibrium in the junction is reached when the diffusion rate, the rate of diffusion will be equal to the rate of drift. Still, a potential barrier will exist inside the PN junction. A PN junction as such cannot conduct. If we take two wires and fit it like that, it cannot conduct because there is a barrier created inside the PN junction. So what is the visible question for your board examination? What are the two processes for the formation of a PN junction? Two important processes. So what is it? That is drift and diffusion and drift. So hole diffusion to this side, hole drift to this side, and electron diffusion from, what is it? Electron diffusion to this side and electron drift to this side. Hope you have understood it, and we are coming with our next session. See you soon.